Hi, you guys, and we are going to be talking about basically 7.3, but I want to touch on lesson 7.2 that we are skipping. It is talking about a cube root, and a cube root is when we have something like this, our same square root, but the index is 3. So this right here is called the index, and that tells you how many times you are using the number as a factor to get this. So like we had a square root and we don't necessarily put the 2, it's just understood to be there. So it was a number times itself. In this case, this index means that I have to multiply a number by itself so that I have 3 factors of that number. And I don't know that we talked about this before. Under here would be what we call the radicand. And this bar here that we have is called a radical sign. I couldn't remember if we talked about that or not in class, so I want to make sure that we define those. So a perfect cube then is when we have the index is 3 and they are integers that we multiply together to get that number. So for example, if we had this, the answer to this would be, we have to think to ourselves, what do I multiply by itself where there's 3 factors of it that it gives me 8? And that would be 2 times 2 times 2, because 2 times 2 is 4, 4 times 2 is 8. So since I know that I'm multiplying those, the answer to this would be, that would equal 2. So the cube root of 8 is 2. That's what that would be. Okay. So I just kind of want to talk about cube roots. They might come up in a couple things that we do when we're problem solving, but otherwise we don't have to remember perfect cubes yet. I did want to introduce that. All right, so lesson 7.3 is using Pythagorean theorem. So I know that a lot of you, when you come in here, have already heard of Pythagorean theorem. This works for right triangles. In a right triangle, the legs are the shorter sides, and the hypotenuse is always the longer side. The sides of a right triangle have special names. So what we mean is this one and this one are the legs. The legs are also, not only are they the shorter, they're also always connected by a right angle. The hypotenuse is always the side that's opposite of the right angle, and again, it's going to always be your longest one. Okay? Now, the legs, it doesn't matter which one you say is A and which one's B. They're basically interchangeable. So it doesn't really matter, but once you identify it, you want to keep it that way. The hypotenuse is always considered RC in Pythagorean theorem. So the Pythagorean theorem says in any right triangle, the sum of the squares of the length of the legs is equal to the square of the length of the hypotenuse. So therefore we get a squared plus b squared equals c squared. So how do we use this? Finding the length of the hypotenuse. So this comes in handy a lot of times. In fact, Mr. Anderson just said that he used this the other day when he was looking at making something for the background or for the backstage of the musical that's going to take place. And so if we wanted to find this here, this hypotenuse, we would start by writing the Pythagorean theorem. We would substitute 5 for A and 12 for B. So we would get 5 squared plus 12 squared equals c squared. 5 squared is 25 plus 12 squared is 144 equals c squared. So we evaluated the powers. We're going to add these two. So 25 plus 144 is 169 equals c squared. Now we're going to find the positive square root of each side. So we're going to do the square root of 169 and the square root of c squared, because this is saying that 2c's equal this. Okay, and we don't want the 2c's multiplied together to get this. We want to know what it would be, the square root of that would be. So the square root, hopefully you remember this, is 13. And so C is equal to 13. So the length of the hypotenuse is 13, and that would be meters. So I would like you to pause the video, and I would like you to do it on your own. You're finding the length of the hypotenuse in both of these, and you're going to turn the page and do that on your own. So go ahead and do that now. Okay, so now if you did your on your own, number one, you would substitute the 8 and the 15, which is 64 and 225. Add those together, you get 289 equals c squared. Then remember, that's c times c. So we want to find the square root. The square root of 289 is 17. So c equals 17, which is 17 feet. Now with fractions, we're going to kind of do the same thing. So 3/10 squared plus 2/5 squared gives me 9 100ths and 4 25ths. But to add fractions, remember you have to get a common denominator. So I'm going to make this into hundredths. So 25 times 4 is 100. 4 times 4 is 16. 16 plus 9 is 25. Keep the 100. Now, that was 25 hundredths, but we have to find the square root because that was 2 c's. So 25 hundredths, the square root of 25 is 5. The square root of 100 is 10. 5/10 simplifies to a half. So the answer would be a 1/2 inch. Okay, the next part of our lesson is finding the length of a leg. So this time we're not finding a hypotenuse, we're finding a leg. So we have to look at what we don't know. We don't know a, so a squared stays a squared plus 2.1 squared. Now how did I know that that was the leg? It's because there's my right angle. Remember, the right angle connects the legs, equals 2 and 9/10 squared. And remember, the hypotenuse is always the longest. Then we're going to simplify. So a squared plus 2 and 1/10 times 2 and 1/10 is 4 and 41 hundredths equals, and 2 and 9/10 times 2 and 9/10 is 8 and 41 hundredths. So now what we would do is we want to solve for the a squared. So we're going to subtract 4 and 41 hundredths, subtract 44 and 41 hundredths. Those are gone, leaving us with a squared equals, now when we subtract this, we get 4. This was a squared, and remember that's a times a. We just want a, so we're going to find the square root of both of those. So a is equal to 2. So the missing length is 2 centimeters. Okay, real life application. You are playing capture the flag. You are 50 yards north and 20 yards east of your team's base. The other team's base is 80 yards north and 60 yards east of your base. How far are you from the other team's base? So draw the situation on the coordinate plane. Let the origin represent your team's base. Okay, so the origin right here is your team's base. From the descriptions, you are 20, 50, and the other team's base is 60, 80. So again, you here, the other base is here. Okay, so draw a right triangle with a hypotenuse that represents the distance between you and the other team's base. Okay, and the lengths of the legs are 30 and 40. So we come up with this triangle here. Okay, use the Pythagorean theorem and find the length of the hypotenuse. So a squared, let's say this is a, 30 squared, plus the other leg, 40 squared, equals c squared. Okay, because we're looking for the hypotenuse. Okay, so we're going to, 30 squared is 900, 40 squared is 1600, equals c squared. Add those, which is 2500, equals c squared. Now we're going to find the square root to get that down to just c, And C equals the square root of this is 50. So you are 50 yards from the other team's base. So if you were using a calculator to figure that out, you would, let me get a calculator really quickly that has a key that you would be using. So you can bring a calculator in. This is the best calculator. Oh, here's a better calculator. Okay, so if you were on here, you were using your calculator, you do have a square root sign. This one, if you notice, is a square root, and it does have a spot for the index. So this one right here, if you can see, oh, you can see better. So this one is if you want to change your index, so if we wanted to find a cube root. This one here is just your regular square root. So you want to use your second button. So we were going to do the square root of 2,500. So what you would do is you push the second button, and then you put this, and now we can enter in what we want to go under the radical sign. So 2,500, and then we can push equal, and it tells you that it's 50. So that's kind of how you use the calculator to find square roots for the ones that we haven't memorized. Okay. So that's 50 yards. So go ahead and try number 3 and 4, and you're going to try those on the next page. Okay, and if you tried 3, 4, and 5, there are your answers. Started the right round one there. Go ahead and take a minute to look through and check your answers.